I would like to introduce results of 3 project. You can see the name of the project, but project try to analyze geothermal potential of Czech Republic. It was a joint project of our institute with Czech Geological Survey, and with this idea came up to light our colleagues from Czech Geological Survey. They promised to find new data, new temperature data from some boreholes. We were skeptic, we didn't believe that. And the main results of this project are new maps of heat flow and temperature maps at the depth, at different depth levels. You can see it. The project is ending this year. We can divide it, the project, between among these stages. The first stage took maybe more than 1 year, and it was tasks for our colleague from Czech Geological Survey, and it was really detective work because they was going through more than 5,000 reports, electronic or printed, to find some new, for us new, unknown temperature records. Then, in the next stage, our work began, and we selected usable temperature logs, and then we continue to estimate thermal properties, and then we could construct our maps. The last stage is again on our colleagues from Czech Geological Survey, and they developed interactive web application based on our data, our maps. You can see the results of the first stage. We divided our country to 15 squares. The side of the square is 100 meters, and the green kilometers. The green dots. This is our database, a database of our institute, and the blue dots. There are new temperature data from this project from the Czech Geological Survey. The red dots. It's visible that there are data of this heat flow from IHFC Commission. We use it for interpolation of heat flow on the border. This is an example of the data. Unfortunately, the many boreholes were unusable. You can see it. This is an example. This is a cluster of boreholes from, I think, East Bohemia. There are many boreholes with overflow, inflow, and there are some strange shape of the geotherms, uncalibrated probes, and not equilibrated boreholes, and so on. Here is the same situation from another point of view. This is one of the squares. There are data. There is 49 boreholes in this square, and only 6 boreholes finally were used for our maps. Now, here is an example. Maybe this is one of the best catches which we obtained from this project. This is a borehole somewhere in northeast Bohemia. You can see this quite deep borehole, more than 2 kilometers. And in this case, we were able to measure thermal conductivity on the cores because Czech Geological Survey has some core deposits, and we have agreement to obtain cores from these deposits, and we can measure thermal properties on this cores. And in this borehole, the borehole is in sedimentary rocks, most of the borehole, and here there are very compact sandstones with very low porosity. And you can see the high thermal conductivity, and heat flow is about 80 milliwatts per square meter. This is a nice data. Now, beside this historical data from the project, we could work with we did some new measurements in the last 3 years. Mostly, there are examples of 4 new boreholes in West Bohemia. The boreholes were drilled under the ICDP project, mostly about 400 meters deep, and the boreholes are in crystalline rocks, 3 of them in metamorphic, very anisotropic rocks. You can see on the left side of the picture the core from the, I think, Studené borehole, or Kyselá borehole, and one of them, Libá, is in granitic rocks. The big advantage is that the boreholes are fully cored, and we are able to measure 10 or 20 samples per every borehole. Here you can see final selection of the boreholes. Unfortunately, boreholes, the distribution of boreholes is not so good. You can see that many of them are located in sedimentary basins because of survey on coal, oil and gas, or water. And we have many places, many white places without data, mostly in crystallines, rocks, in plutons, when we are interested in. Finally, there are the number of boreholes. Our previous maps were based on 189 temperature logs, and under this project we obtained another 96 measurements, and final number of boreholes is here. We did standard procedures with the data. If it was necessary, we did corrections for the effect of topography. We did 3D numerical models of surrounding of the boreholes with topography realistic on the surface, and the temperature of the surface was reflected the altitude and longitude. And after the computing of the models, we were able to correct the data. The next step was estimation of thermal conductivities. The best way is, of course, direct measurement on cores. We are able to do it on the new boreholes and in several boreholes from this project, and this work will be continued because we have agreement with Czech Geological Survey, and they will serve us to cores from deposits, and we will measure. But if we don't able to measure directly, we used our database where we have almost 2,000 measurements on different kinds of rocks. And from the Czech Geological Survey, we obtained lithological profiles of all boreholes. And we could compare geological formations, and we compare the rocks, and we could set the values of thermal conductivity. And the third way was rock composition analysis. You can see here, this is from coal basin close to Pilsen, and this is in Czech, but there are different kind of rocks, sandstones, claystones, coal, and here's a thermal conductivity computed, gradient, and heat flow. So here you can see our map, heat flow map of Czech Republic based on this data. And the next step after this was to construct the maps of temperatures to different depth levels. This is a very, very sad picture, because here you can see all boreholes in Czech Republic deeper than 2 kilometers with temperature logging. There are 161 boreholes, but 159 are located here in Southeast Moravia because of oil and gas survey, and only 2 points you can see in Bohemia. This is the situation. And it means that if we want to estimate temperature to depth, we need heat flow, and we need to estimate thermal properties. This is nice colored picture. Here you can see thermal conductivity in 5-kilometer grid. This is based on uncovered geological map, and we obtained from Czech Geological Survey the grid with geology, and then we assign the thermal conductivity to these squares. You can see places with lower conductivity. This is Triassic tertiary basins, Czech Cretaceous basin, and so on. And another input for our maps were presence of sediments and different depth levels. We are able to prepare grids with thermal conductivity at different levels up to depth of 3 kilometers. Under this depth, we assign uniform value of thermal conductivity. And then we could construct the maps at the different levels. Here you can see the temperature at the depth of 1 kilometer. It corresponds with heat flow map and with the low conductivity in tertiary basins. Another picture is temperature at the depth of 3 kilometers. And another is temperature at the depth of 5 kilometers. It's a big difference from something 50 to 200 degrees of Celsius. The fifth stage was to create application, and here you can see the result. This is interactive application where everybody can combine the maps. On the left side, you see our maps, our temperature maps, heat flow map. This still is only in Czech language. And it's possible to combine with some conflict of interest. I mean, some nature protected areas, some army areas, I know, so on. Here you can see the example. There is a map. It is a map in the depth of 5 kilometers, and these places with uniform color, there are some nature protected areas. It's possible to combine with geological map, with some cadastral maps and many other maps. And everybody can create something like virtual borehole, because if you fill the address, or if you fill the coordinates in this square, you can do temperature profile in this place. And I'm going to conclude. It's clear that we didn't expect that we'll found a lot of data, but we found it. It led to significant changes on the heat flow map. And the third point is publicity done by this application, but I don't know if it is good or bad, because immediately after the publication of application, we are asked by journalists, by authorities, by majors from cities about utilization of geothermal energy, because imagine that every major can create virtual borehole in this city, and he wants immediately geothermal power plant. And it is it is not so simple. And our ongoing work, the question is about data reliability. We will discuss about it all over meeting, I think. Boreholes are quite shallow. We will continue in measuring of samples from Czech Geological Survey. And the map of heat flow was without paleoclimatic correction. We are now working on it, and now we were asked to create detailed temperature maps of the shallow depths with the reflection of elevations, of altitudes, and reflections on thermal conductivities and so on. And we would like to fill white places on the map. We negotiate about the new project. We want to drill about 10 new boreholes, 500 or 1 kilometer deep, in the mostly in crystalline rocks where we don't have data. Thank you for your attention.